This is Brook from Printrbot.com, and welcome to Printrbot Live. It's been a little bit since I've seen you guys. I was just writing some notes down, so hold on just a second. I said the Big E, the Crawlbot, and
3D printing in the classroom was
oh, yeah, I've got that.
Okay. Adopt-a-bot.
Oh, yeah. All right. Oh, yeah, that's right. Okay. All right, so let's start. I'm Brook Drum, and this is Printrbot Live. So first off, I just wanted to say happy holidays. Specifically now, I guess I can say Merry Christmas. I enjoyed my Thanksgiving. I was gone last week. I took a vacation, first one in a very long time, and it was pretty fun. I got to go see my daughter, and she's doing well. My newly married off daughter, Sydney. So it was really great to see her, and now we focus on Christmas. So I hope you guys had a good Thanksgiving, and Christmas is coming. And you know, our Black Friday sales this year were a little bit different. We didn't do some, you know, I'm a little sick of the Black Friday. I saw so many stores doing the, you know, Black Friday week and then pulling it through the weekend and then doing Cyber Monday and then Small Business Tuesday or whatever it was. It was just too much for me, so I kept it simple. One new product, it's sort of a new product. It's come and gone, to be honest, but I wondered if there were people that wanted the Simple Pro without the heat bed. So that is for sale now, and it is really getting close to, if you remember the price on our old Simple with no heated bed, was, I believe it was, how much was that? $5.99? Oh, well, that's very close. In fact, exactly that. $5.99 for a Simple Pro. I have one up there, without the heated bed. Now, the reason I did that was I was really excited to get the heated bed. Now that that's done and it ships with, you know, the higher end model of the Simple Pro for $6.99. Is that right? Yeah. I realized that when I print, I don't use the heated bed because when you print with PLA and you're doing smaller parts, you know, pretty much don't need a heated bed. I say pretty much you don't need a heated bed. Now, if you do large parts, they warp a little bit. So I just thought, for me, I like to sell things that I want. I did those 500 prints for Autodesk, and I didn't use a heated bed on any of them. And so when I was tending the farm, I thought, why aren't we selling this? This is a great printer. It was outperforming my old Simples and my old Plays. I got a few of those in the bot farm. Some of them with upgrades, some without. I do have some with heated bed, but I stopped using the heated bed on the Simples and Plays too, those that were upgraded. So I've got that in the store for $5.99. So if you're looking for a Christmas printer for your kid and he or she has never 3D printed, it's a great place to start. With that $5.99. Now, I know it doesn't, you know, it was funny because I put that in the store and then I asked, hey, did we sell any, you know, non-heated bed Simple Pros? And Dave said, no. And I asked myself, why is that? Well, it's only $100 more, I guess, for the heated bed, and you can't buy that. You can't buy it for $100. So I don't know. Maybe there's somebody out there that does not want a heated bed, period, and they want to save $100. So, well, that's for you. But anyway, so we didn't have any big announcements on Black Friday. We're selling the Simple Pro. We've got the Adopt-a-Bots for sale. The Smalls is really coming to an end. The LE was limited edition, and while I said, well, I guess we're done with those, they didn't really sell too well. It was a little bit high priced. It was reviewed by the Make Magazine Digital Fabrication Edition, and you know, got good marks. And I love that printer, but for $500, you know, it's a short leap up to the Simple Pro, which is a much better printer, all rounder. So anyway, that LE's gone, and the Smalls is going away. The files are online, of course. We've got a few more to sell, don't we? A couple? Yeah.
We likely will have a handful left.
Yeah, there's a handful still left in the store, but
Well, they're out of stock right now.
Okay, yeah. We've got a few more to put up for sale. So while they're out of stock right now, there'll be a few more. So if you're an educator and you've got a small budget, I'm really looking to push those folks that don't want to build to the non-heated bed Simple Pro. It's more money, but it's a lot better printer. Now, not that the Adopt-A-Bot sucks. I'm not saying that. But the Adopt-A-Bot is so cheap. If there's like, I don't know what I'm doing with 3D printing. I want to buy for an American company. I want to just bottom dollar, see if I'm interested in this. The Adopt-A-Bot is still a solid choice. Now, concerning the Adopt-A-Bot, we are shipping them. In fact, Dave told me he's got a few going out tomorrow. So we've got a big stack of them, and we're shipping those out. And I realized that some of you folks that were on the Adopt-A-Bot program, in other words, this has been kind of I don't want to say half-baked scheme, but it was something that I've always wanted to do. I want to build a really, really cheap printer, design it, open source the plans, but I wanted it to be as 3D printed as you could really possibly make a printer. So that printer is designed now, the version 1.2. You have to look on the blog on adoptabot.org to get those files, because I haven't made it more prominent yet. But those files are out. It is a finished design, and it is really all about getting printers into the hands of students in schools. So I do want to highlight that those are for sale. They're kits. You have to print. Here's the idea. You print the parts yourself, so you'll have to have a 3D printer. You assemble it, and there's assembly required. You don't even have the printed parts, and that's most of the printer. So it's really like this ultimate bare bones. We've upcycled some parts. I think the ones that up till now moving forward, we might have to use a different hot end, but we dug up some old ceramic hot ends. So it's really like the lowest bar there is to get into a 3D printer in the U.S. So anyway, those are for sale. We do ship those. We expect you to print them, assemble them, and then since you're paying for them, if you're not just a builder and you want to donate to a school, that really makes it possible for you to spend a little bit of money, put in some sweat equity, and spread your passion for 3D printing to a local school. And once you do that, give them your number. You're the guy or girl that's going to support that school. And so they may choose to do some more. Maybe they can build their own. Maybe you'll build another one for them. But I know that we have some builders out there that signed up on the list. I just checked the list. Heather printed it for me. Can you hand me that list? I think it's about, she said, oh, she gave it to you. I thought that was it. There was like 40-some people that said, hey, I don't want to buy them, and I don't really want to support a local school, or I don't have kids, or I don't have investment in a local school. You should, but if you don't, there's some people out there that just wanted to print and build. So we do have more Adopt-A-Bot kits to send out to you. And I will not charge you. I will just ship them to you in good faith. And then you will wait to hear about what school that I need to get those printers to. And I'll ask you to ship them to the school. So a little bit of work involved, but that's the whole deal. You're doing something good with your 3D printer for local schools. So that's the Adopt-A-Bot program, and I wanted to give you an update. If you're on this list already, I've got your email and your name, and I'm going to reach out to you and say, hey, you still up for this? I'm going to be shipping out parts and spending shipping dollars to get these 40-some people these printers, and I want to make sure that you're good to go. And if you want to donate that to a local school, I do, it's really something I need to get some money for, so I think it's $98. So if a school wants them, I need to charge them $98, and then we'll get them that printer. So there'll be some schools that don't have anybody supporting them, but I'm okay with that. If they're up for it and they have somebody they can call on, maybe it's a student that has a 3D printer, and that's fine with me. So anyway, I want to, I was hoping to ship 100. I've got a list of 40-something here. And I don't know how many we've shipped, not a ton. I had a bunch, anyway, it doesn't matter. But we have not and will not, based on if all of these people say yes, we will not get to 100 by the end of December at this rate, folks. So if you were waiting for the time to either buy one on Printrbot.com, I didn't have a checkout system on adoptabot.org. So you go to Printrbot.com, look for Adoptabot, buy that, we'll ship it to you, and then you take care of the rest. But if you're a builder and you're on this list, we'll be contacting you. So if you didn't know about any of this and you want to get involved in the program, well, the easiest way is just buy a printer. It's $98, print and get her done. If I assume you're watching, you have a 3D printer. So anyway, that's that. I don't have a way for people that just want to build and get a kit to contact me yet. We didn't set up another list or anything, but I'll ramp back up my MailChimp or my email newsletter and get everybody updated in the month of December, so you know what's going on. But it's a reality. It's happening, and I don't mind if it ends up being small. I'd love for it to grow, and I'm encouraged that I have things to ship like right now. It's great. That's always the hurdle. But we did it. So I've got 100 printers, printer parts, waiting. Probably over half of those aren't in a box yet. I think 25 or something were in boxes. But anyway, so I have them. I'm ready to put my money where my mouth is and send those out at a loss just to help local schools. So get involved. Adoptabot.org or Printrbot.com and look for Adoptabot. All right. So the next thing I wanted to talk about is, this is a lot of talk today, huh? I was reminded today, because we sold a couple of the new high temperature Ubis 13. And I was hooking this up today on, believe it or not, a Simple Pro. And there's some caveats to that. So I wanted to talk about my experience and highlight this little hot end. So first off, I had some, you may have seen me show this unit in a past show. Well, that was the beta. Carl gave me a couple of betas, and he's got, I'm sure he has one that he's printing with because he tests everything. But this is the final production version. So what's different? Not a lot. One interesting thing that he's done lately is instead of, there used to be a little tool that you could get that you could like insert into one of these holes and use it to hold things firm while you got to heat it up, while you loosen this tip and change out the tip. Well, he said, forget that. He put some flats on the side here so you can just grab that with a wrench, and it's a slightly wider OD, outer diameter, so you can just use a wrench to hold that while you loosen that. So that's one change. The other change on this particular hot end, now we have this double-sized, it's like twice, I don't know if it's exactly twice, but it's roughly twice the height or the length of the Ubis 13S, the hot end, the melt zone. That's what I was looking for, the melt zone. So we've done a high flow, and that's for sale now. It's a 33-watt high flow hot end. That's in the store. If you're looking to print faster and you want just to move faster and print faster, it's always, I think, you got two options. It's easiest to just add a bigger tip. But you're not going to be able to compare apples to apples with a tip at 0.4 and a tip at 1.25 or 1.0 millimeters. Because the volumetric flow isn't linear. It's when you have a bigger hole, you're moving a lot. Like if you had twice the size of the hole, 0.8. We don't even sell that. But if you double the size of your hole, it's not double the size, double the speed, or double the volume. It's more than double the volume. So it's a little bit hard to compare. If I just size up my tip, can I print faster? Well, no. There's a certain point at which if you use a bigger tip, you have to slow down because a heater can only do so much. The melt zone is the most critical metric here on hot ends. You can't pump an infinite amount of heat into plastic on a given length of melt zone. You have to lengthen that melt zone because the faster that filament moves through there, that plastic has to absorb the heat. And you need a longer melt zone. So a lot of people used to brag about, oh, I've built a smaller hot end. I've got the smallest hot end. There was Pico and like all these derivatives of designs that came out. And Carl and I would always just laugh and like, they're making a less and less and less effective hot end. This is fantastic, because you're going to have to move slower to allow the plastic to be in that teeny tiny melt zone longer to get enough heat into that to go through. So you can make a very precise, very slow, very short hot end, or you can try to really push the heat. I know E3D used to, not to bag on them, but E3D used to make the V, I don't remember what version. I've only bought 2 of theirs, and one's in a drawer and one I gave to Carl and he threw it out, or he looked at it. But we don't buy competitors' stuff and try to rip it off or anything. I wanted to see what they were doing. Well, they were doing a 40-watt heater, and they have a cartridge heater. It's a Chinese heater. Carl hates those for the reason they burn out too quickly. And understand, Carl Ubis, he does all of my hot ends. He's a genius. He used to work at HP in the printer failure lab. So he would measure this component versus that component on a lot of different things, price and performance and all that, but also length of life. And he's very sensitive to things that inherently in their design, they will fail. So he uses this, it's wire that wraps around, what's that called? It escapes me, the type of wire. Nichrome. He uses nichrome wire and wraps it around, I think it's aluminum spool. It's not as likely to fail when you have it around that, what did I call that? A bobbin, as opposed to smashing it into a little bitty cartridge, and it's heating itself mostly, and then the residual heat gets out through that little canister. This is providing heat uniformly all the way around the brass, well, first the bobbin and then the brass hot zone or melt zone. So it's more efficient. And so to get higher flow, E3D did a 40-watt cartridge heater. Well, it was too high because it pulled a lot more amps, and they kind of quietly backed it down to a lower wattage. So you would have to have a bigger, some of the electronics, they have limitations on how much wattage that you can pump through to the hot end. But more importantly, a cheap PSU or power supply has limitations. So when you were using an ATX power supply from us, let's say our early one was 350 watts, you bump up to 40 watts, that has a significant impact in the amperage that you're going to pull on that PSU, and you hit a ceiling and you get some failures. You have a power supply that browns out and says, too much amperage. So anyway, we have a high flow hot end that is 33 watts. And it does a better job than our competition because of the more efficient heater, but also very specifically because we can be efficient, but we can also have a longer melt zone it works better, and you can go faster, if that makes any sense. The longer the melt zone, the more heat is applied to the plastic, and the faster you can go push plastic through that melt zone. So these are double the length. Now, we did a special order version of that high flow for Jeff at Create O&P. Check them out if you're into prosthetics and orthotics. They exclusively sell the Model 1400 prosthetic printer. They're gray. It's a custom version of the Plus Pro. I've limited the Plus Pro to a 12-inch build height. He has a 14-inch build height. He uses a custom-ordered hot end that's more powerful than the one that I sell here. Mine's 33 watts. His is 45 watts. So you can get that through him, but I'm not selling those. Why? Well, because 33 watts works as a swap. A high-flow hot end works as a swap in any of your printers. So if you have an old Simple, a Play, whatever, and you want to go faster, you will need a high-flow hot end, the 33 watt that I sell in my store. It has double the melt zone, and it's slightly higher wattage. Now, that is good enough for me. You can have an ATX and use a heated bed, and there's plenty of power in our, well, I don't even sell the ATX anymore. We have a 350 watt Meanwell 12 volt power supply now. But whether you're running a heated bed with one of those or just a cold bed with the hot end, 33 watts isn't going to overwhelm the power supply. So you can do high flow with that hot end. Now I recommend a bigger tip, by the way, because a 0.4 tip and a high flow hot end, you will be able to go very fast. But to go even faster, if you can give up a little resolution, get a bigger tip. And then you can push a lot more. No, I'm busy. You can push a lot more plastic through that high flow hot end at 33 watts, and you don't have to worry about getting another power supply or if you're going to hit the how much wattage that you can push through it. So anyway, that high flow hot end is for sale. But this one is the high temp. And what's different in this? It's very significant, by the way, because check this out. 33 watts for our regular high flow. Yeah, there's a 45 watt if you go through Jeff. But the 33 watt, we jumped to, from the 33 watt, we jumped to 90 watts on this hot end. So this hot end requires a larger power supply, but a special power supply, a 24 volt power supply. Instead of just do this incremental bump up in a new hot end, I wanted to go all in, and so this is 24 volts. I'll tell you how that works in a second. It is 90 watts, and it is all metal, so there's no PTFE. There's no sleeve in here. This is all metal. If you remember, we did an all-metal hot end years ago, and then I pulled it back because it was a shorter melt zone, and if you did too much retraction, PLA specifically could stick to the metal. Well, we have learned some new ways to polish the interior of this aluminum heat break here. I'd say heat break, cold zone. But check this out. So it's a stainless steel. Instead of brass, this is a stainless steel melt zone and heat break. So it's very, very thin-walled here at the heat break. The heat break is when you go from the part of the aluminum here. This is anodized aluminum, and then it has a very, very small diameter. It's laid, it's machined down to a very, very slim stainless steel wall. And so stainless steel is a horrible, I say horrible, it's not the best conductor of heat. It's actually an insulator. So we use brass on all of our other ones. But this stainless steel works really well. Since we've got so much power, 90 watts, it's not a problem getting to temp with the stainless steel with this heater. And it also acts as an insulator for this melt zone. But it comes up into the aluminum. And then on this particular model, we have, because of the machining and stuff we have to do, we put the plastic cap, which disappeared for a while because we would put a PTFE tube up through the bottom. We did away with this cap, but this is a plastic cap on top for even further insulation from the extruder, because we have some plastic extruders, or maybe you're 3D printing your extruder, so that cap helps insulate if there's any heat creep up. Now this is cooled with a fan. So anyway, 90 watts, stainless steel instead of brass, and aluminum, no PTFE, a cap here on top of Delrin. So there's significant differences, and it goes on. Also, this is, I think, one of the best things Carl has done, this right here. This is, and it's rather long, but this hot end goes to 500C. Now, I may have said 450C before, but since then, Carl's done some more testing. He's like, 500C is no problem. Now, when you go up beyond 270C, our normal hot ends are rated at 270C. And the reason they're rated that is because the thermistors that are commonly used in 3D printer hot ends, are 100K ohm 1%ers. We use an EPCOS, I think it is. Anyway, we use a typical, it's like number 6 in the Marlin lookup table. But anyway, we use a typical thermistor for below 270C. When you get up above that, even a 1%er, which operates within a certain band of temperatures, it starts to drift because it can only be 1%, 1% across that many ohms. You really start to get off the mark when you get up towards 300C. If you go above 300C, which we limit that in our firmware on our regular hot ends, but if you go above that, you start to drift 5, 10, 15 degrees off the mark, and you're going to be wildly inaccurate in your temperature reading. And so you won't be able to dial in the real need of a filament that calls out a specific temperature. Okay. Man, this is getting geeky. Dave's like, oh, yeah. But anyway, so this one is really cool because it uses what Carl has told me not to refer to as a, what's it called? PT1000. He said, don't call it that. It's not that. And I said, okay, well, what is that? It's sort of like a thermistor, but a PT1000 actually, well, let me go all the way, a thermocouple. Now, when you buy an E3D, I guess I'm looking like I am picking on them, but they're major competition. Are you comparing to the standard V6 or the Volcano? Well, this would definitely blow away either of them. The V6 is, very limited. What they did on the Volcano, I don't really know their product line that well, but I do know that the Volcano is the one that they say is the really, really high flow. So if you own one of those, you'll have to tell me what tip you use, and really we need to compare volumetric comparisons. So how much volume per second, or can you extrude? Or we could say at 100 millimeters a second, or 50 millimeters a second, and a 1 millimeter tip. No, it's the other way. With a 1 millimeter tip, how fast can you print at what layer height? You got to lock down 2 of those and just talk about the speed. But I guarantee you that 90 watts is going to outperform anything they have because they don't have anything like this. They don't have a melt zone that's anywhere near this size, so it's not going to compare to this. And I don't know of anybody that's stupid enough to release a 2 millimeter tip for 1.75 filament, but that's what Jeff uses in his prosthetic printers. How can we do that? Because if you flatten off the top of the tip and you've got a 2 millimeter tip and you're doing spiral prints, which is what Jeff does, and you don't have to worry about ooze too much because it's always moving, always extruding, you can really pump out a lot of plastic. In fact, even more than you're feeding. So the feed is really faster than in fact, in the slicer, you have to say over extrude, like 2.0. And so you have to trick the slicer so that it prints and everything looks good. He gets I forget if it's 3 or 4 millimeter single wall width. So how do you get 3 or 4 millimeters out of 1.75 millimeter? You push out a lot of plastic. So anyway, the point is that this has a very special temperature sensor, and it's not a PT1000 because, or it's not a thermocouple, because the thermocouple measures voltage, and it is like micro voltage. It is like the smallest differences in voltage. But to be able to use a thermocouple on a hot end, you have to have another piece of electronics, because all printer electronics, I shouldn't say all, but almost all, they measure temperature with thermistors, which is resistance, or ohms. And thermocouples measure like micro changes in voltage. So thermocouples are out because that's hard, and you got to use extra electronics. But these PT100s and PT1000, E3D only sells a PT1000. I believe that it still uses, it's like this, that it uses resistance, but the band of resistance is different because they have to translate with another piece of electronics. But that's the beauty of what Carl did here. He has manufactured his own temperature sensor that has the proper resistance, so you don't need any extra electronics. So now you can be very, very accurate. It's a actually I think it's even better than 1%. I don't want to give data on the testing because frankly we haven't used it enough, but he says it's better than 1%. And when you go up to 500 degrees C, which think about it, that's a lot. What is 500 degrees C? It's a lot of it's a lot of Fahrenheits. And that's a high temperature. How can you be accurate? What is it? 932 Fahrenheit. I mean, and it can go higher, by the way, but we just like, what plastic needs that? None. Literally none. I mean, this will literally, it's the highest temperature that I know of in the pyramid of plastic. You get up to, PLA is way down at the bottom. You get up to peak and ultim. This will print peak and ultim, no problem. In fact, it does more heat than it even needs for that, so you could print even faster. So you show me an E3D that costs, what does this cost? Thank you, Dave. We don't even know our own prices. You see how concerned I am with money? Is it 100? 99?
I'll look at it right now.
Okay. Coming soon. Okay, $99 for this alone. Show me a E3D product that can print peak, has 90 watts, has a 1% temperature sensor that doesn't need any extra electronics. It only just needs an update in firmware. The lookup table is different. Yeah, it does exist. So these come assembled. A lot of E3D's kits are just that, kits. And so believe me, the magic of Carl is not just the science that he uses to design these things, but the way that he puts them together. And there's a post-processing procedure that even happens to get all the diameters right. And it's how he puts them together. So you want an assembled hot end. Now, it is easy to change out the tip. You can change out tips. But let me tell you on this one. So it's all metal. I've got PLA in here. You really need to dedicate to avoid the problems that comes when switching plastic. You really need to dedicate one hot end for the temperature band that you're going to be printing in. This is printing at 200 C. But imagine if I just pulled that out and put in peak, and now I got to go to 450 C to print peak. You know what's going to happen to that PLA in there? There's little residual on the wall, even though it's polished. There's a residual of plastic that ends up sticking to the walls, and usually you're in the same temperature band, so you just push it out, and then once you've kind of purged the old plastic, then you're ready to go with the new one. But the new plastic doesn't move until it hits way up there. 350, I think it was 350 C. I forget. There's different temperatures for different brands of peak and ultim. But anyway, on the way up, it's starting to soften, and that PLA is going to char and turn into carbon. And then you're going to try to push it out a 0.4 tip. Hopefully you have a larger tip, and maybe it's not going to be a problem. But if you push it up to the high temperature, it's going to just burn in there and char. So now you can clean it out with something else. And there's, believe it or not, there's filament that is just used to purge and clean, and it doesn't leave as much a residue as like a black PLA. But we're going to ask you if you have some things that you print in ultim or peak, and you have some things that are way down there at 200 C for PLA. You really need to buy 2 of these and just swap them out. Now, the leads on this are longer because when you get up to such a high temperature, you do get actually some heat creep that goes up the wires. These wires are like the size of a human hair. They're so very small. They're in an insulator, but they're so fragile. You got to be very careful with this. In fact, we even run, there's a sleeve. I don't know if that's fiberglass or what that is, but there's a sleeve that runs on the outside of the fiberglass insulator. And even this fiberglass insulator has a temperature. It's going to degrade over time if you're running at 400, 500 C. Really, to be honest, 350 is about as much as you'll print with because that's what the highest plastic needs. But let's say you're running close to 400C. Over time, this thing is going to have to be replaced because it'll break down. But this sleeve coming out of the temperature sensor protects it. So keep it on the outside. Be very gentle with it. It's longer than you've seen on our thermistors because of heat creep. So we have to make them that long. Otherwise, it's the same. Maybe it's a different gauge wire, but it's the same nichrome wire. We have some extra insulators. This is silicone insulator here. So, a lot of little nuances here in the high temperature, Ubis 13 high temperature hot end, and I wanted to go on at length about that. Yeah, if you can tell, I'm excited. But here's the mistake I made today. I hooked it up to a Pro, and I thought, I think I had some GT2 boards that I had Nick a year ago do a 24-volt version because there's some capacitors that need to be spec'd a little higher to go to 24 volts. But I didn't really know if my power board on the Simple Pro would take 24 volts, so there was one way to find out: plug them in and turn it on. And so when I did, the first thing I did was I plugged this power supply we use for the CrawlBot. It's 24 volts. I plugged it right into the board. Well, the polarity is reversed, so you can imagine how that went. Pop! And smoke was released. Then I remembered, oh yeah, we got that voltage polarity switcher with the tab here. It's plus coming out, and we need that plus to be on the bottom without the tab. That's the ground. So anyway, once I got this, I plugged it in, switched out my power board that I popped. It does work. You can power up if you had my 24-volt G2 board, you can power up the power board with 24 volts. I don't recommend it. Something's going to pop. But I wanted to hook this up to the Simple Pro, and I forgot about this. So we're going to add this when you buy this 24-volt power supply. If you'd like to run this on, like, say, your old printer board, the old printer board can accept 24 volts out of the box. The thing that keeps it from being able to be used with 24 volts is several things. If you got a heat bed, you don't have a 24-volt heat bed. You got to get your own. Now we have this adapter this adapter takes the 24 volts, proper polarity, connects to ground, which we connect right there, and the FET on the old printer board switches ground. That's common in 3D printers. They lift the ground. And so when it says turn on, then it closes the loop and sends all the power. You can just use your regular power wires plugged into there, and it sends that 24 volts straight to the hot end power. Now you've already changed your lookup table, the firmware with the new lookup table, so you can just run the wire from the new temperature sensor down to where the thermistor plugs in here, and you're good to go. Well, I didn't do any of this on the Simple Pro, so now I got to get a version of the Simple Pro with the proper lookup table and make sure that all of the components in there are spec for 24 volts. But that's what I did today, and I ruined a couple of boards, and well, one at least, and wasn't able to print because the lookup table was wrong. So anyway, I'll get this going where you can use this on a Simple Pro if you have one, and really that is the key to unlocking the G2 board. This is a printer board. I need to unlock the ability for the G2 board to print with 24 volts, and then we're having a party. We got new abilities with our printers. Wow, that was a lot more information than I expected. Now, if there's anyone left, is there like one guy left in the chat room now? Maybe two. Anyway, I just thought that I would finish out telling you about a couple of things. I've talked about Adopt-A-Bot. Next week, I'm going to start a 20 to 30-minute series. Not a live series because I'm too unscripted to be able to make any sense of. I won't be able to do a tutorial in 20 minutes. We'll have to edit it. But it's going to be entitled 3D Printing in the Classroom. Along with Adopt-A-Bot, I know that one of the barriers to 3D printing in the classroom is knowledge. It's not just cost. It's really knowledge. Now, I think the number one is people. People with experience is the number one thing that we need to get 3D printing into the classroom. I think the number two thing we need is affordable printers. Some schools will be able to afford a printer, but they don't know anybody that knows 3D printing, so it's in that order. First, you got to have a person, then you got to be able to afford them. But the third thing is a little bit of training, a little bit of general information, very basic stuff. This won't be for you advanced users. It'll be from the perspective of somebody just getting into 3D printing. It'll answer some questions. Now, other companies have done this, and some of them have done it well. But I wanted to do one from my perspective. I don't know another CEO of a 3D printing company that loves education more than me. Now, I don't know that many, so maybe it's easy. I just haven't met him yet. But I know, maybe a dozen. And when they say schools, they think, oh, money and contracts and like that's a large audience and everything. I don't think that way. I think of kids and these young minds that are going to open up. So I'm going to give my own perspective. That's why I'm reinventing this wheel. And also, when people do come to buy from me, they benefit from getting to know me a little bit and the philosophy of Printrbot. So we do things a little bit differently. This will be a series of, I don't know how many, but just a very basic, sit down, you don't have to know anything, and we're going to get you comfortable with the idea of 3D printing and cover some common, maybe things that you overlook as an educator, maybe just some terminology that you need to learn, and even the tools. Now, when I get to the printers, of course, I only have 3D printers built by me. So it'll be Printrbot printers, but the course will be agnostic. I'm not trying to give you incentive to buy a Printrbot because then you've got some training that goes along with it or introductory stuff. I'm doing this because I believe in the cause, and I think it'll be agnostic for whatever printer because the tools are pretty generic, unless you buy something proprietary, like MakerBot has their own stuff. I'm not trying to get you to buy printers. I'm trying to get kids excited and educators excited about bringing 3D printing into their school as another tool to teach. So that will just be called 3D Printing in the Classroom, and it will start next week, 20 to 30 minutes. So you can check that out. Anyway, that's pretty much it, but I wanted to give you a few teasers, and if you've got any questions, get them in now, because I always provide time at the very, very end to answer any questions that come up. It can be anything. So if you got any, Dave, put them up. But we're going to go about another 2 or 3 minutes and be done. Yeah. So here's the projects that I'm looking forward to next year. I know it's a little early to talk about next year, but Christmas is here. We're building what we're building till Christmas. I don't have to really get anything new out, although my hope is the Printrbot will be out before Christmas, but you know me. It may not be. So the number one is get the Printrbot out. We're waiting on some material. Had some equipment failures this week. I thought I was going to come back from vacation and be printing on that 12 by 12 inch Printrbot. That wasn't the case. We can't run a water jet without a compressor. Got that fixed. Now we're waiting on material, which should be here this week or tomorrow. So that's job number one, Printrbot. Job number 2, 3, and 4. I want to rev the Crawlbot and bring the Crawlbot 2.0. I'm not going to give you details, by the way. I'm just telling you that there's a new version coming. Here's the things I want to change. I've been talking with TinyG, and right now the Crawlbot uses a V9 TinyG. Well, the printer board that we have is much more advanced. But if you want to use step and direction to run, you don't have to know what this means, I'll tell you. If you want to run bigger motors, I use NEMA 23 motors right now in the V9. I want to run bigger motors in my Crawlbot 2.0. You have to use external drivers, and it has to accept step and direction, the bare minimum from the CPU or the printer board, as it were, the electronics, to execute the G-code. Well, I'm going to move to external drivers because then I don't have a ceiling on what size motors that I use. So I can do faster Crawlbot. I can do more powerful Crawlbot. That's what I want. I want to dump the belts. I want to get rid of the belts. So that's the part I'm not going to tell you how because I'm not really sure yet, but I have an idea. So anyway, it'll be, I have no idea how much it'll cost. Don't ask me. But it will be more powerful and more of a serious, we've got our legs wet for 2, 3 years now, our feet wet on CNC, but we want to have the best motion control. We want to have more powerful motors and drivers, and that is going to have to, we're going to have to move off of the V9 and into the next generation TinyG board, which is an ARM processor, and it's a very powerful ARM processor. And I'm really looking forward to that. So that's one project that you'll see next year. Another one that's related is I do have a desire to do a smaller, no external drivers, but a smaller CNC again. I feel like I just missed the mark with my Printrbot CNC. I missed it in price. We built one. We were kind of, you know, I know one of the guys that, what did he do? He did one of the tabletop CNCs. I know Zach Kalpin ripped them off and got into a whole kerfuffle with the, I forget what it's called. But anyway, there's like a cheap one that you can buy. Well, those were too flimsy for my taste, so we built a really powerful, like very rigid Printrbot CNC, and you could, you know, mill aluminum with it. But it's too pricey. So I'm looking to do something that's more precise, smaller. So the bar is lowered, no metal, but you could do precision CNC, PCBs and such. So I'm going to at least experiment with that and see if we can come up with something that's in a palatable price range, because there's a gap between, you know, the $200, $300, $400 CNC and the Crawlbot, which is, my gosh, what does that cost? Off the top of your head, Dave? Crawlbot cost? $4,000. There's a big gap. So I need something for beginners, or at least for, you know, people that are looking for something that isn't 5 foot long. So anyway, I would love to get back into CNC, and that new board from TinyG has some really interesting specs that I could run some smaller motors and just do some superior mechanics, ball screws. I don't really know if I'll use ball screws, but maybe ball screws in a smaller unit. So that's another project, but depending on that TinyG board. And then the last thing is the Big E. So they're all kind of related. They're moving, well, it's related to the Crawlbot in this sense, the Big E 2.0. So I did this crazy, a couple years ago, thing called the Big E, and the idea was to eventually put a pellet extruder on it. So I want to follow through with that and finish that pellet extruder. Now I do have some help from oh, I forgot there was one thing I wanted to talk about. Dang it. Philibot. Anyway, so Philibot sent me this huge pellet extruder, and they're, you know, experts on extruding pellets and making filament. And Tyler's a great guy, and so I gave him a Big E, and he gave me this huge, it was just really heavy pellet extruder. Powerful, but like it was big. And there was no way I could put that on the Big E. The Big E was kind of flimsy. It was like very, very, very low bar. How cheap can you make a very large printer that prints in feet, not inches? So I couldn't put the, you know, this hot end would actually be great to put on the Big E 2.0, because if you go up to a 2 millimeter nozzle, you can still use 1.75 filament. You got a lot more power, 3 times the power. That might be a good fit, but I still want to do that pellet extruder. So next year, I'm going to try to see that goal achieved, where we've got a bigger Big E, but much more rigid. Much more rigid. And you can do big prints with either the high temp hot end, or you can go to the pellet extruder. So that's some big goals that I have for next year. Just wanted to tease you with, see if anybody's interested. Questions? Will something replace the smalls? In a word, no. Now, I will say this. I don't know if you follow the 3D printing world, but here's what happened. We beat everybody to the $300 printer. You know, this was the first version of it, but we made this little itty bitty, I called it the Simple Makers Edition, you know, 4 or 5 years ago. And it was a kit. It was laser cut wood. It used string instead of belts. Stupid idea. I mean, it worked, but it was a pain. Still some people printing with it today, but Kevlar, pretty good, but not as good as belts. So we kind of beat everybody to the punch on the $300. We sold thousands of them. It was ridiculous. It was crushing. There was no margin in a $300 printer. Now, China came in and basically beat all of us to the bottom. And I have well, I do know how they do it. They don't pay the labor that I pay. I won't go into detail, but they don't have the EPA regulations. So there's a lot of things that were in play in China to be able to produce a really crappy printer at $200 or $300, or maybe even $99. But I'm telling you, those are crap. So I wasn't okay with crap, so I upgraded my cheap printer, and it got to be more money. Eventually, we came out with the, wherever it is, Simple, made in metal, costing more, $600. We were very happy in that middle space, but it became apparent that there were some problems with the $500 printers, and specifically ease of use. Now, we upgraded it dramatically and eventually came out with the Simple Pro, which has excellent hardware, linear rails, touchscreen, which means you got to use a cloud service if you want to use all the touchscreen stuff. But you can print with USB, fine. But for those newbies, they could actually print. My wife could finally print with that printer. So we worked on ease of use, and we used a 32-bit ARM chip, and we went sky's the limit. Everything was very, very nice, but it's expensive. So the Smalls is kind of like a step back in this way. It was $298, so the cheapest printer that I've sold. So it got that price, but really, if you're looking for a cheap printer, and price is the only thing that's really keeping you from getting into 3D printing, just go buy a crappy Chinese printer, or build one yourself. Find one of those companies that do a $200 or $300 Prusa knockoff, which also will not be that great of an experience. There's a mono price printer that's okay. They should be ashamed of themselves on their hot end. I'm tweaking out on these really nice hot ends. Their hot end sucks, and you won't be happy with it. But there's a bunch of upgrades that you could do. Print yourself, get on sites that sell better hot ends, do modifications, blah, blah, blah. But that's a very small niche. If I'm going to do business for a long time, I've got to keep my eyes set on the coming consumers, people that have no experience, and they're not going to upgrade their printer. So yeah, it's not really even a decision that's hard to make because the Smalls don't sell that well. If you want a $300 printer, you probably are going to have more choices than you know what to do with. I'm just a small fish in a big pond with those $300 printers. So no, we're not going to keep making them. Oddly, they take longer to build than my nicer printers, because with my nicer printers, we design them to be manufactured, not to be built as a kit. So we take great pains to spend a little extra money so that we can build more of them more quickly, keep that cost down. So that's my thinking, but the answer is no. Any updates on the removable bed plates? No, I am sorry that I do not have any more updates on that. Will we do it? Yes, we will. But I'm one of those guys that I don't even hide my failures, and I've failed to get that out. I'm not going to BS you. It's just not ready. What was that other one? Spring steel? Yeah, we're talking about I intend to support the legacy printers with sizes of the spring plate that you can use on your Play, your extended Play, your Simple, your Plus. We'll make them in small quantities. Here's the caveat to those is I did have some spring steel that I did not dry properly after water jetting it when I was doing the betas, and they did rust a little bit on the edges. At least one that was here did. So I was like, I can't do that. So then I sent them out to be nickel plated, and boy, they're beautiful. It just takes a freaking long time, and it's very expensive, so it drives the cost up. I could cut one of those tomorrow for you. It just might, if I didn't dry it right, it might rust later, and that bugs me. So that's the caveat. I have all the drawings done. I just have to get together a bigger order, figure out how many I want to order, and get them all nickel plated. Hey, Brooke, just wanted to say thanks. Well, you're welcome. I don't know what I did, but you're welcome. Oh, thanks again for helping me replace my YZ. Don't read that fast, Dave. It's kind of like a teleprompter, but Dave's at the helm there, so it's like, whoop, whoop. My YZ block from my Simple. Yeah, if you've got one of our old, Dave's going to cringe at this, but I really do want older printers to work. So if you've got a problem and I don't sell the part, just contact me. It's Brook@Printrbot.com. And more than likely, or
for those specifically, I've been meaning to ask you.
Yeah.
We have a few, and there are, just today I had to send
Well, here's the thing with those blocks. They're very expensive to make. They're $11 a piece, my cost. Now, that may seem cheap, but I got to mark those up to stay in business. So it's going to be over $20 if I sell them. I think 22 or something like that. Now, that's just the part. Then I got to put the bearings in, which I have to pay somebody to do. And those bearings, you may only have one bearing that are bad. You can't press these things out on your own. You have to have this special jig to get these bearings in. They're even harder to get out. So we've had some here that one of my employees didn't install properly. So I got a whole bunch of those with one bad bearing. So what do I got to do? I got to make a jig, this tool to extract the bearings and press in new ones so I can sell the rest of them. But I bet I have 100 of those that some of them might even be scratched, but they would work fine if I replace the bearings. So I do have a bunch of those. I don't want to sell them yet because I'm embarrassed that I only have a few of them that are brand new. I have a lot of them that are used. I got to pull out a bearing and fix that. And then those would be cheap. So I might sell them eventually, but I do not want to abandon anybody with one of my legacy printers. It's 5:30, we got to stop. I don't want to abandon anybody that bought a printer. I believe in buying a used car and driving it into the ground. I don't believe in buying new cars, when the fancy new one come out. So that's how I do business. I want you to keep that Printrbot running as long as you can, and I will help you get the parts to do it. Luckily, there's a lot of parts that are out there on the market elsewhere. Stores that specialize in little bitty parts. That's not my business. I sell printers, assembled and done. But if there is a unique part that only I can get, I'm going to keep that in stock for a long time. And if I have to make more YZ blocks, I'll make them. Next question, is this the last one? Or you got another one? Oh, okay. Last question, and then I'm out. Can you print all of the parts for Adopt-A-Bot on the smalls? Yeah. You can. In fact, you can print all of the parts for the Adopt-A-Bot on the Adopt-A-Bot. Is that nuts? You can. I designed it that way. In fact, it's a little harder to print, or no, it's longer to print. There's more parts than really need to be. Somebody out there with a simple metal, should take my parts and mash them up so you're not splitting parts where I have to split parts. You could probably print it faster, at least not have so many plates or so many prints. But yeah, it prints, I believe it's like 95 by less than 95 X and Y to print that, so you could print it on a smalls, no problem. So that is the end. And thanks for joining me. Sorry that I just talk a lot. Nothing really to show except that hot end this week, but have a great week. Look forward to doing an edited video series beginning next week, 3D printing in the classroom. It'll have relevance for other newbies as well, but I'm focusing on education because I think there's some specific questions that need to be answered. If you have, I'll set up a way to get feedback on that too. Actually, YouTube does it. So I'll be watching the comments in YouTube on that video series to make sure that I'm steering the boat in the right direction. So if you got comments, just share them on the YouTube and I'll respond. But that will be 2 videos a week, 1 live and 1 edited. So that's where we're going. Anyway, have a great weekend. Thanks for joining us and happy printing.